Welcome back, Generals, to another Let's Fix Generals 0 to make the best game ever. Good. So I built Generals here. Set up a start, blah. Okay. Let's try. Play game. Save. Save game. Lone Eagle. Save. Load. Load game. And indeed it hangs. Huh. Okay, that's interesting. Let's see why that is. That's FPS limit. Yeah, that doesn't count. Oh, looks like a game state is stuck. How is this stuck? Present. And render. Is it stuck in a loop or how's it stuck? Load screen update. Update load pro start new game. Okay. And let me free this again. Okay, so this is bug. Major. Gen. Okay. Why is it stuck? So yeah, start new game. Update load progress. Okay. Update load progress. Load screen progress 0. Update. Display update draw blah 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 draw yes. Percent. Let's see. Is there a loop here or not? Let me put a breakpoint here. Yeah. Okay. 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 Yeah. Yeah. Continue. Freeze time. True. This game hold it true. Okay, so it's an infinite stall here, infinite loop. Yeah. Because freeze time is true. Oh. Mm-hmm. I think what's interesting is here that in 0 hour this problem doesn't happen, so that's weird. But the code would be very similar, I assume. What is the purpose of this freeze time shit? So what happens when I'm building complicated logic here? Yeah. Yeah, this needs to be removed, but we don't do this now. No. Trying to think of like maybe some intermediate change that we can do to mitigate this. I Game is halted. Why is the game halted? Because it's cached. This rendering function is retarded. This is absolutely retarded bullshit here. This loop. This is retarded down here. Yeah. Yeah. Yeah, I can't wrap my head around this right now. Yeah, this needs. I need to investigate this another time and get back into this code. It has been a minute that I looked at that. I'm not ready to dive into this again. There was another easy change I wanted to do. Okay. Okay, good. Let's search for game logic, CPP. So I want you to remove unnecessary game logic pointers. Hmm. What's this? Updates. Okay, anything else? Maybe we should make a pass over all types. Oh. So here we have the subsystems. Maybe what we can do is we take this. Yeah. And then we work through all of these guys one by one. So we start from the top. We start with the version. Go to version. This one looks fine. Next one. Subsystem list. Subsystem. System list. Okay, that's weird. Okay. Okay, I think that's correct. The file system. Okay. Local file system. Okay. Next, name key generator. Is it static? Oh, it is. Static name key. Okay. Okay, static functions need that. Command list. Okay. Next. Writable global data. Okay. Static. Okay. Okay, that's fine. Game load manager. Okay. The fuck is this? Okay. Game text. Okay. Okay. Next, science store. Oof, that doesn't work. Oh, science info. Let's see. Static. Okay, that's fine. Next, multiplayer settings. Okay. Global language. Okay, that's fine. Next, CD manager. Audio. Okay. Function lexicon. Module factory. Okay. Message stream. Okay. Sites list. Okay. Cave system. Okay. Yeah. Particle, okay. Particle, yeah. Particle system references. Particle system manager. Okay. Okay, I guess all of this shit is fine. FX store. Oh, what is this here? Weapon template. Okay. This one looks unnecessary here. Weapon store. X virtual. Oh, that's weapon. Never mind. Next. Okay. Locomotor store. Okay, fine. Special power store. Okay, fine. Okay. Armor store. build assistant. Think factory. Okay. Upgrade center. Yeah, okay. Game clients. Okay. The AI. Okay. Oh, that doesn't work. Static, okay. Okay. Next. Game logic we already did. Team factory. Okay. Create system. Okay. Playlist. Recorder. Radar. Victory conditions. Meta map. Meta map. Action manager. Game state map. Okay. Game states. Game state mission save. Yeah. Static. Okay. The audio. I think we already looked at that. Yeah. Okay, I think that's it. Yeah. Okay, there were a few things, so I guess it's fine to clean that up. Let's see if it still compiles though. Mm-hmm. Create branch. Refactor. Remove unnecessary global reference, global ref. Refactor. Remove unnecessary global references. Remove unnecessary. Remove superfluous global in singleton classes. Let's change. Just removes. Edit the pass on all singleton classes. And these are all I found. As seen in game engine in it. In it. Is that right? Yeah. Mm-hmm. Game logic get frame. Pass in directory is a static function calling static functions. Static, yeah. Okay, cool. Then that is done. is this? Camera edge scroll broken. It's a bug report. Okay. Mm-hmm. Mm-hmm. It's allowed to adjust destination. Okay. Good. Then what about this one here? Set trainable, reset trainable, is trainable. Is trainable. Can I gain experience? Set trainable, reset trainable. Okay, let me get a clear view on this. Take the comments above the function. Just trying to find an occurrence where we added something. Right trigger, set trainable. Is trainable. Reset trainable. Okay. That makes sense, yeah. This looks very solid, very nice. Can I add comments above and describe what behavior with workers this avoids? Is it also properly initialized in the constructor? Yeah. Does it only have this one constructor? Yeah, I guess. Okay, cool. Let me see this. I did mainly a refactor in there. Okay. Okay, this looks good to me. Okay. Then let's go back to our work in progress camera. Let's actually get latest main branch first. Per rebase. I think we can delete this copy here. Yeah. Good. Then we do a stash. No, we do a rebase. And then we do a stash pop. And then we do a compile. Good. Let's get back to height map. Where were we left off? We were investigating performance, right? When we oversize terrain, it needs to process the whole height map again and do a whole lot of calculations. I think we probably optimized a fair bit now already. So it probably will be faster, and it probably already is a lot faster in release anyway, without debug, right? I expect it will be faster. But how about we make a new performance capture and check what is now left over, if there's anything else we can optimize. Yeah, I suspect we probably eliminated, I don't know, 20-30% or so of the costs. Maybe. It would be nice to see like how much it is in total, like in milliseconds. Okay. So what do? We run. Yeah. Good. Then let's take a bigger map. Let's take our DEFCON 6. Then yeah, the stall is already a lot less. There still is a stall, but it's not all that bad. Let's make a measurement and see what big positions we have left. If you remember, like in an older video, there was like significant stall when we did this. It's still stalling, and there still is a visual glitch we need to look into, but it's already a lot faster. It feels like, I don't know, 200 milliseconds, 300 maybe. 200, yeah. Let's put a record CPU profile. And let's do a few of these. Yeah. Okay. Break. Okay, and then we go to, where do we search again? Oh boy. So there's memset, which is expensive. Search oversize terrain, right? Mm-hmm. Oversize terrain, init height data. Okay. How can we look inside? Huh? Functions. Ah, flame graph, right. There we go. Here. There we go. Okay, what do we have here? So init height data, init refresh route. Okay, so that's a big position. Do the light. Do the light. Okay. This one we can ignore because this one was a memset. Yeah, we ignore that. Do the light. Okay, so do the light is a very big position. We can look into that. And then refresh route. Yeah, okay, so 2 more candidates here. Do the light and refresh route. Surface class drop picks. Well, there's a lot of small things here. What is this? Clamp. Clamp is expensive. It's probably just the sheer volume of this function. Do the light. Let's take a look at it. Do the lights. There we go. Oh boy. All right, I remember we added this clamp here. Yeah. Well. Clamping appears to be very expensive. So the dot product is expensive. I don't see how we can optimize individual things other than, again, thinking about pre-computing something. Calculates a diffuse lighting for a vertex in the terrain. Calculates a diffuse lighting. Okay, maybe we can pre-compute that as well. Taking all of the static lights into account as well. Static lights. Okay. It is possible to just use the normal in the vertex and let D3D do the lighting, but it is slower to render and can only handle 4 lights. Okay, this to me sounds... So, what do we give it? We give it a light. Let me Let me watch this here. Oh boy, do the lights. Ugh. What is this light? Is this like an array or what is this? Oh, it's just a light. Oh, okay, it's just a light position. Okay. There's the normal. Do the light. The calls to do the lights, the inputs, are they also coming from all our pre-computed shit? Alpha. Alpha comes from pre-computed. This taxonormal comes from pre-computed. Light ray. Well, that's not pre-computed. That's position. Okay, I'm confused about this. What is this? Why is this light ray? Why is it taking minus all these chords? What is this? I don't understand this here. Oh, we should rename this to get pre-computed. Now, what do we rename this to? Get pre-computed taxonormal. Oh, it's consistent with the other guys. Okay. To a fix-up commit. Okay. So let me get back to the slide here. So everything, so this guy is pre-computed, the alpha is pre-computed, only the light iterator is not, and this light ray is not. Terrain light force. Ugh. Why is global lights? Why are they in global data? What the hell is that bullshit? What's 3 global lights? Huh? Ah, it's like a sun or something like that, right? Light ray minus light force. Minus light. You know what I don't understand? This loop here, why is this in here? It's a const reference here. Light ray. To me, it looks like that this shit here needs to be moved up here. Here. Can I move this here? Yeah, because this never changes, right? This is always the same bullshit here. Yeah, I think. Then also this is totally overcomplicated here. We can simplify this to this and then do that. No need to make it more complicated than it needs to be. Boom, done. Then we move this down here and then boom, just like that. It's already much simpler. Is this being done also in other functions? Or just here? It's also done here. How about we put it into a common function? It's also done here. Bridge buffer. So I would say we do the following. We take this shit here and we add a new function in here and we call it protected or public static updates it's more like filling an array here. It's to struct terrain light race terrain light race get terrain light race do it like this, and then we create this guy here, and then do this light index blah race right ray maybe we do initialize it to 0. Then we add this here to the bottom. Okay. Okay, and then okay. then we can do we can now replace this guy. Let's do it in the other functions first. So here, base height map. Then we have this. Light ray. Let's call this light ray. Okay, we have that. Then we remove this. Then we have this light ray, and then now we call light ray dot light ray. Maybe we give it a different name in there. Light ray. Vector. Vec. Let's call it deer. Deer. Right. Race. Okay. So we have that. Then we do the same here. Light ray. Okay. Get terrain light ray. And then this one will be light ray dot race. Okay. Okay. I think that's it. And then this one here. That means this one needs to get hands on base height map. It already has height map. And height map has base height map, right? Hello, can I go in there? Height map. Height map has base height map. Yeah, okay, so we already have access to this thing. So here we do a base. This one, terrain, light ray equals get terrain light ray. Then we remove this, and then we use this here dot raise. Okay. Okay, I think this will work. Let's see. Okay, this will already bring a bit performance. Yeah, because it's quite an expensive loop, but it doesn't compile. Undeclared identifier. Max global lights. Global data. Well, global data. There we go. Okay. Still an error. What's the problem? Oh, right. Don't know how that happened. Still fails. Must return a value, of course. Return, let's call this ray lights. I think we can remove global data from here. Yeah, here. Okay. Okay, cool. Let's see if that still works. No, it's very quiet here. Look at that. That means I'm not bombarded with new things, and we can actually maybe look at something older, some older things. Let's take a look at this here again. Did you check that? Okay, let's take a look at the change. Move for swap. Okay, cool. Swap, 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 empty. Adds inline keywords. Multiple times. Okay, cool. There's a conscast here though. Conscast here, so we can move the path coordinates into storage. Is it worth it to do this? Otherwise, I would say leave the copy. Yeah, so basically we can do the copy, we can do the move here, where we pass this like this, right? That's fine. Yeah. Keep AI palms cons. What is this? Why is there this comment here? Oh, we have a crash. Look at that. Well, that's not good. Vector was null pointer. Oh. Raise. Why is it crashing? What? Why is raise null pointer? What is this? Vector. It thinks. Oh. Okay, this is not doing what I expected it would do. Okay. Well. Memset. Why don't we just do for light index smaller than array size, raise. And then here we simply do dot zero. No, don't we have a zero function? Vector 3. Zero, zero. Let's just do a Let's do a memset. Let's do a memset light index relates this comma 0 comma size of vector 3 times array size minus light index. Yeah. Set the rest to 0. It should work. Array size. Let's put a breakpoint in here. So num global lights is 3 actually. Look at that. So this then should say 3 minus 3 is 0. Should memset 0. Right. Why don't we just copy all? Smaller this. That would be much safer. Yeah. Just copy all of them. Then we don't need this shit here. Can also do a static assert here. Size of race equals size of global data train light pass. Ugh. Correct array size. Mm-hmm. Mm-hmm. Then here we say array size. Mm-hmm. Okay, I think that's better. Mm-hmm. Mm-hmm. Let me also consolidate this again here. There we go. Mm-hmm. 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 Okay, cool. This looks correct now. Yeah. Okay, cool. Let's see if everything looks normal. Mm-hmm. 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 Okay, cool. Then let's finalize this one change. Blah. We need to clean up the mess here. Mm-hmm. 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 Okay, so we take these guys and we take take this. Mm-hmm. Mm-hmm. Take all that and that. Okay, then we call this optimize terrain light ray terrain light ray query. I don't know. Mm-hmm. Okay, commit that. Okay, and then the next one would be, let's go to do light again. Do the light. Where it's called. Do the light. So if we pre-compute this, what is done with the light rays? Let me see. Light index, num global light. Mm-hmm. It also loops multiple times here. So, I mean, if the global lights, if they don't change, then if the global lights don't change, then we don't need to. Then we don't need to. Don't need to recalculate it, so we can just do it once. Yeah, so this looks pretty static. This one looks static. What about this one? P-lights iterator. Ah. There's a null here. Lights iterator. Oh shit. What is this? Lights iterator. Okay. The lights iterator is a problem. Everything else is static except for this shit. Wait, it on every tile it will do this, do the light on every tile. What the fuck? Oh. Oh. Hmm. So the problem I see here is that we go through all tiles, and then in every tile, we then also iterate through these lights. So let's say we have 30 lights here. Then on every tile, it iterates then also through these lights. And then it checks, is the light on this tile, right? VB. Yeah. Ugh. Same. So there's ambient light on the train, and then there's a dynamic light. Lights iterator. Okay. So I guess it's not possible to do a 2-pass to to do it in two passes, where first we go to all the ambient lights, and then afterwards we just go through the lights, and then we just revisit all the cells that the lights are positioned on, and then just add the dynamic light on top. That would be the more efficient approach, right? But then, by the way, there was one function here with the bridge buffer where I did the normalize. Is this normalize actually necessary? Let me go here. Here, light ray. Is that normalized or not? Looks a bit long, doesn't it? I'm not sure. Maybe put a breakpoint here. See if that changes anything. Well, this would crash if it was 0, right? So this better not be 0. Well, it's not 0. Also not 0. Okay, so it's a minus 0.4, okay. Okay, looks pretty much the same. Minus 7.9, 6.2. Some 8. Okay, it's a bit shortened. Yeah. 814834. 814834 is just a bit different. Yeah, I think it's close to normalize, so I don't think we need to normalize here. Should be good enough. Yeah. Can expect it normalized. Okay, let's go back to do the lights. Where's it? Find. Do the lights. There we go. Okay, so yeah. Would it be possible to split this? What is this doing effectively? This one will affect the shade. Oh boy, shade. Add in global diffuse value. Global diffuse value. Add in global diffuse value. Diffuse. So I think part of what is so expensive is this iteration, depending on how many light iterators we have. And then the other is this stuff here. Yeah. Yeah. Shade. Right. Yeah. I think what we should do is we should pre-compute the static light. And then we just slap on the dynamic light by just iterating the light iterators, figuring out the tiles that this affects. Yeah. This will be a bit bigger change. Yeah, but it should be possible. Yeah, I think we need to do it. Yeah, we first pre-compute the ambient light, and we store it as we store the ambient light. What a position. Oof. Mm-hmm. Mm-hmm. Yeah. We pre-compute the diffuse light. The light probably also needs to be updated when we modify the terrain, but that is fine. And then, what do we? I don't know. Maybe not. Yeah, and then I think so, because you see this one is darker, right? Because it's more in the shade here, this. So I think when we modify terrain, we need to update the ambient light. Yeah, and the dynamic lights, that we can't pre-compute those because they pop in and out all the time. But and then basically, so this one is just adding the stuff, right? So we have diffuse. Yeah, so this one we can just add to the diffuse. It doesn't matter the order, whether we add it here first or this first, it doesn't matter. Yeah. We store it with clamped. Yeah. Yeah, I think this will work. Yeah, yeah. Okay. Good. No updates here. Good. No, I didn't further look into this one here. For swap. Keep a commands const. It's a bit confusing. I understand what it means. It means that this argument of this function is meant to be kept const. Of this one is meant to be kept const. And that's why it's creating a copy so that it can pass it in here. Yeah. I either remove it or rewrite it. I don't know. Yeah, not a big deal. Const here. Okay, good. Then I will end it here. Has been 2 hours. Yeah, we got a bit of stuff done, did a bit of thinking. So next session, we will do this a diffuse light, static light optimization first, and then the dynamic light optimization pass afterwards. The good thing is, so it will completely get rid of of the static light calculations. So all of this no longer needed at runtime. And the beauty of this one will be that we only need to iterate the lights iterator once, visit all the tiles that are affected by these light iterators, and then just process these guys. Whereas right now what it does, it goes over all tiles and it visits all light iterators on all tiles and checks if the light iterator affects this tile, which is extremely inefficient. Because imagine you have, let's say your map has 100,000 tiles and you have 30 dynamic lights. I think the max is actually 20. So let's say there's 20 lights, yeah? So you have to do 20 times 100,000 this iteration. So there's 2 million iterations to go through this, even though it just affects a few tiles. So it's extremely inefficient, which probably is not a problem right now here when there's no lights. Yeah, when does it do the lights? I see no light on the Humvee here. There is light, yeah. Okay, I'm surprised that it's not calling this here. So lights iterator is always empty, or what is this? Lights iterator. It's empty, yeah. Okay, and under what conditions do we have lights here? Let's load some dark map. Like, I don't know. Town and city, yeah. Maybe it's not used, this feature. Where is this coming from? Let's put a breakpoint here. So who's putting this there? Here, create lights iterator. Okay. Light list. Okay. So what about this light list? What is this? Why is this empty? Light lists. Oh man, how much is the okay, so there is then a light. So this is not a dynamic light, it's something else. What is this? What is this light list? So there's dynamic light list and there's light list. How do we create a light? Standard scene lights. The question is how are these created? Maybe it's a feature that was never completed. Standard scene lights. Standard scene light. Okay, well, let's take a look next session. I will end it here. Good. Then I wish you a great day or night. Until next time. Goodbye.